Good afternoon, everyone. Am I audible?
Yes, sir. Good afternoon, sir.
Good afternoon. Okay, so in the last lecture, we have discussed about different kind of leases, starting from advanced reservation lease. Then we have discussed about various variants of best effort leads. Then we have discussed about deadline sensitive leads, period reservation, token reservation, negotiated leads, soft and hard deadline leads. And we have also started discussing a particular problem in which we represent a lease in the form of six tuple, right? Like here you can see the lease one is represented in this six tuple. Like first we represent lease ID, and we represent the arrival time and start time, then deadline, then what is the duration that we call as period, and number of nodes. And I also told you about how to solve this problem without applying any algorithm. Okay, so in that problem we have seen that out of these 7 leases, 6 leases are accepted and 1 lease is rejected. But I told you that you can try some other method without looking into this algorithm. By our aim is to make more leases need to be accepted, right? So our expectation is that 7 out of 7 leases need to be accepted. So have you tried any solution after the last class? Have you tried? Last class we have discussed one solution. Okay, and I told you to solve the problem by without looking into the different type of algorithm. So you have to apply your thinking that how we can accommodate these 7 leases. So last example we have seen 6 out of 7 leases are accepted, but we need to accept 7 out of 7 leases. Anybody tried? Those who are present, please respond. Have you tried? Say yes or no. Vishal? Okay. What about others? Junali, Isa? Okay, you have not tried. Have you understood the previous solution? Yeah. So let us see otherwise, if you have not tried. And I also said today, you a set of leases, which I shown you in last lecture. So that in the group, I have said that 4 different files. One file is having 13 leases. Another file is having 23 leases. Another file is having 33 and 43 leases respectively. So you have to try your own solution, and whatever algorithms we'll discuss in today's class, you have to try these algorithms and prepare a report kind of thing where you can specify how many leases are accepted and how many leases are rejected. Okay, with their lease ID, so that we can look into whether you have done it correctly or not, that we can check, right? Okay, so there are 3 different algorithms that we are going to study here. Like you are given with a set of leases. On the other hand, you are given with a set of nodes, and you have to assign these leases to the nodes, right? You have to assign the leases to the nodes in such a manner that lease rejection ratio is minimized or lease acceptance rate is maximized, right? So there are three algorithms we are going to discuss. The first algorithm we will discuss, that is called as Haizea. Okay, this Haizea is a open resource manager. I request all of you to download Haizea into your system, into your Ubuntu system or Linux platform, and try to run these leases, at least these 13 for 23, which I said with you, 13 leases, 23 leases, 33 leases, and 43 leases in this Haizea platform. Okay, and show me the results, right? So if you run these algorithms into Haizea, Haizea is having a default resource allocation policy. Okay, it is having a default resource allocation policy. So based upon that policy, it is going to alert 13 leases. It tries to alert the 13 different leases into a 4-node cluster. Similarly, you try with 23, 33, and 43. So first, when you deal with these leases, you have to arrange these leases in the increasing order of their arrival time. Like here you can see 7 leases are there, and they are ordered based upon their arrival time. Okay, or you can say non-decreasing order of their arrival time, right? Why I'm saying non-decreasing order? Because at a particular instance of time, you may have more than one leases. Now, if there is a tie in the arrival time, then you have to look into the start time, and based upon the start time, you can decide which leads need to be scheduled first and which leads need to be scheduled after that, right? So let us discuss the first algorithm, Haizea, and let us understand that what is the drawbacks of this Haizea default policy and why we need an improved resource allocation policy and compare the performance with the Haizea. Okay. So if you go for Haizea resource manager, this is the algorithm. I'll tell you the detailed algorithm in the later slide. But theoretically, when you receive a deadline sensitive list, DS means deadline sensitive list, when a cloud service provider or a resource manager like Haizea receives a new deadline sensitive list, the existing algorithm, or you can say this is nothing but the default algorithm that is available in Haizea. And Haizea handle this deadline sensitive list by finding a single time slot to satisfy the whole lease. For example, if you go for lease 1, let us go to lease 1. Lease 1 start time is 9 and deadline is 10:30. Let me write here. The start time is 9 and the deadline is 10:30, right? And another two parameter, one is P, that is period, which is 40, and number of node n is equal to 1. So P is your 40 and number of node is 1. Now what this point says, this is a deadline sensitive lease. Okay. By looking into this lease, you can say that it is a deadline sensitive lease because it has a deadline parameter. Although when you go for, I can say soft and hard deadline lease, okay, soft and hard deadline lease, SSD lease, in that case also you have deadline. But there are two type of deadline at that in the lease. One is soft deadline, another is called hard deadline. On the other hand, that soft and hard deadline lease is having a violation factor. Okay, 0.5 or 0.25, any value in between 0 to 1. But in this case, you don't have such parameter. As you don't have such parameter, right? So you can, by looking into this lease parameter, you can say this is a deadline sensitive lease. So what you have to do, you have to find a single time slot. For example, it is asking you within these two, within the start time 9 and deadline 10:30, it is asking you a 40 minutes period. So it may be 9 to 9:40, right? It is a one of the solution. Somebody will say that if I start at 9:10, I'll complete at 9:50. Somebody can say I will start at 9:20 and it will complete by 10. So these all are the valid solutions, right? But we have to think that in which solution is a better one, right? Initially, a four node cluster is completely empty or it is idle. So you can assign from 9 to 9:40, the first solution. But later point of time, sometimes you can see 9 to 9:10, the slot is already reserved. In that case, what you should do? You have to go for 9:10 to 9:50, right? And suppose up to 9:20 it is reserved, then you can go for 9:20 to 10 and so on. Like that, you have to do it, right? So the idea of single time slot says that you cannot do like this, like 9 to let's say 9:10, it is a 10-minute slot, and let's say 9:50 to 10. It is another 10-minute slot. It is a 10-minute slot. It is a 10-minute slot. Total it is 20 minutes, right? Then again I started, let's say 10:10 and 10:30. So it is a 20-minute slots, right? So total it is 40 minutes, right? Or not? So which fulfills our requirement. But this is not a single time slot. You have multiple time slots. So what you have to do when you receive a deadline sensitive lease, in the case of Haizea, first you try to find a single time slot. It may be 9 to 9:40, it may be 9:10 to 9:50, it may be 9:20 to 10. Right? There is no issue. But it should not be splitted like this. Although it is also 40 minutes. These individually they are 40 minutes, right? But here, by dividing them into three parts also, it is 20 minutes, right? That is also a valid solution, but it is not as a single time slot, right? But if you are not able to find a single time slot, okay, if it is not able to find a single time slot, then it will reschedule the already accommodated deadline sensitive lease to make space for new lease. Suppose there are four leases, L1, L2, L3, L4, right? Now you have assigned L1 successfully, you have assigned L2 successfully, but while you are scheduling L3, lease L3, you are not getting any space, right? In that four node cluster, the space is already reserved by L1 and L2. So L3 you are not able to schedule. Not able to schedule means you are not able to find a single time slot. So in that case, what you have to do? You have to reschedule already accommodated deadline sensitivities. What are the leases that are already scheduled? L1 is the lease and L2, these are the two leases that are already accommodated, right? So you have to reschedule them L1, L2. There are two orders to do that one. Either you do L1, L2, already you have done this order, L1 followed by L2. There is another order left, that is L2 followed by L1, right? L1, L2 order you have done. After that, you have seen that L3 is not able to get a space. So you can try the order L2, L1. So it may happen that sometimes this rescheduling is beneficial, right? So already deadline sensitive leases you have to identify and you have to reschedule them, right? After rescheduling, if you are able to schedule L5, then it is fine. If you are not able to reschedule L5, sorry, L3, then you have to roll back, right? L1, L2, you can reschedule and you can give the space to L3 if L3 is acceptable. After rescheduling also, if you are not getting any space for L3, you have to roll back. Okay, roll back to your previous solutions means you will take L1 followed by L2. Right? Like that, you have to proceed. Reschedule the already accommodated deadline sensitive lease. Right? So how to make rescheduling? I told you reschedule. Reschedule means L1, L2 case, you can do L2, L1. There is no other choice. But let us see, there are four leases. L1, L2, L3, L4. L1 is scheduled, L2 is scheduled, L3 is scheduled, L4 is not able to you are not getting any space. That means you are not getting a single time slot. So what you have to do? You have to reschedule these deadline sensitive leases, which is already accommodated. What are the leases already accommodated? L1, L2, L3. So we have to reschedule them. Right. So in order to reschedule them, there are different order will come. You have already tried L1, L2, L3. You are not getting space. You can try with L1, L3, L2. Right. You can go for L2, L1, L3. Like that. How many orders you will find if there are three leases? Can anybody tell? How many orders you will find if there are three leases? How many orders you will find? Please respond. How many orders you will find? L1, L2, L3. 6. Okay. Yes, it is 6. Ronak mentioned it is 6, right? So because it is 3 factorial, right? That's why we are getting 6, right? 3 into 2 into 1. So like that, if you go for brute force approach also, you try all possible one, then L2, L3, L1, okay. Then L3, L1, L2, L3, L2, L1. So total orders you will get here it is 6, right? So you have tried one order already, right? That is L1, L2, L3, and you are not able to get any space for L4. L4, yes. Then you can try L1, L3, L2, L2, L1, L3, L2, L3, L1, L3, L1, L2, L3, L2, L1. Okay. If in this order also you are not getting space, then simply you have to reject L4. But if you are getting a space, then you have to follow that particular order. Okay. So detail about how it actually it performs the resettling, I'll tell you later. Because if there are let's say L1, L2, L3 up to L100, okay, and L101 is coming into picture. Let's say all the leases are accepted, but we are not finding a space L101. So for L101, we need not reschedule all these 100 leases. That is not a good solution, right? If I do 100 leases rescheduling because for LG101, that is not at all a good solution, right? So what are the leases you will reschedule for L101 that you have to think, right? That part I'll tell you in the later slides, right? So how actually we perform this rescheduling, that is an important part. So what Haizea says that in order to perform the rescheduling, you have to sort the deadline sensitive list based upon the slack value. Okay, so you need to calculate the slack value of already accommodated deadline sensitive reach. Those leases are already accommodated. Such leases, you have to calculate the slack value and rescheduling them by considering preemption. Okay, when we say sort is having different meaning. It may be ascending order, it may be descending order, it may be non-increasing order, it may be non-decreasing order, it may be anything, right? So what order you are following here? We are following here non-decreasing order. Sort means you have to sort them in non-decreasing order of their slack value. So first tries to determine the slack value of each and every lead. Right. Once you determine the slack value of each and every lead, you have to arrange them in which order? Non-decreasing order. And reschedule them. Why you are actually finding this slack value? Because you are finding another order. Out of these 5 orders, you will find one order based upon the slack value. Then you follow that particular order, not to go for brute force approach. All possible order you should not check. If you check that one, if the number of leases are 100, it is not feasible, right or not? So we have to reschedule them by considering preemption. Okay. So let us see how to calculate the slack value, right? For example, I am taking this slide as an example, right? So if I ask you to calculate the slack value is nothing but D minus ST divided by P. What is D? D is your deadline, ST is your start time, P is your period. So now can you calculate what is the slack value of L1? Can anybody calculate and tell me? Do it. Slack value of L1 to L7. Can anybody calculate and tell what are the values you are getting? What is the slack value for L1? I already told you formula. Put the values in the formula and tell me what value you are getting. Use calculator if required. What is for L1? What is the slack value you will get for L1? What is the value you will get for L1? Can anybody calculate and tell me? Those who are present, please respond.
Sir, could it be 2.25?
Yeah, first one is he is saying 2.25. So it should be 1030 minus 9 divided by period is 40, right? So 1030 minus 9 is, it is a 90 minutes, right? 1 hour 30 minutes. So 60 minutes plus 30 minutes is 90 minutes divided by 40. So it is 9 divided by 4. So we will get 2.25, right? Similarly, if you calculate for L2, so it is 1030 minus 9 divided by 30. Yeah, 90 by 30 is equal to 3. Calculate for the next one. It is 100 by 30. Okay. L4 case, it is 90 divided by 40. Again, you will get
2.25.
2.25. Yes. Here you will get 3.333. So you can take 3.34, right? And this case, L5 case, it
Sir.
is 16, 6, right?
Yes, sir.
Yeah. So it is 6. So in this case, it is 50 divided by 30. So you will get 5 divided by 3. How much?
1.6.
1.666. You will get, let us write 67. Then it is 30 divided by 20. So I think it is will get 1.5. Yeah. So we got the slack value. But when this slack value is required, the slack value is required if you perform rescheduling. And when you require rescheduling, if you see that one particular lease is not able to get any slot, then only you will perform rescheduling. Otherwise, there is no need of going for rescheduling. Okay, that you keep in your mind, right? You should not go for rescheduling until unless if a lease is not getting space, then only go for rescheduling. If a lease is getting space, don't go for rescheduling. So there is no need of this particular column if all these leases are allotted without any rescheduling. No need, right? But if a lease is not suitable, then you have to find a proper sequence, right? That sequence you can determine using the slave value. So I think up to this it is clear, right? Now, one of the enhancement you can do with this existing algorithm says first one is single time slot. Okay, single time slot. If single time slot you are not found, then you have to perform the process of rescheduling. And that rescheduling is done by using the non-decreasing order of the slack value, right? Now, one enhancement you can do with this default algorithm of Haizea that you have to consider several time slot. That's why I told you this example. If you are not getting a 40-minute slot, okay, in the 4-node cluster, then you can think that we can go for uh, multiple times, several times. Instead of 40 minutes, if we are getting 10, 10, 20, that is a solution. If you are getting 20 plus 20, that is also a solution. Right? If you go for 20 plus 20, that is a solution. If it is 10 plus 10 plus 10 plus 10, that is also a solution. 15, 5, let's say 10, then 20, that is also a solution. Right? 15, 5 is 20, 30. Okay, we need another 10. Okay, 40, that is also a solution. So any combination, if you are getting 40, that is also accepted, right? So one of the enhancement we can think that we have to consider several time slot which together can satisfy the complete list within the deadline. Okay, that is also a solution that you can say you can improve the default algorithm by considering multiple time slot. So if you are doing multiple time slot, then what happens? Resource utilization is increased, right? Whatever utilization we have, that is increased. So for example, if we have a 2-hour deadline sensitive lead, now we cannot find a 2-hour slot in the 4-node cluster which can satisfy that lease within its deadline. But if we are getting 2 time slot of 1 hour each, okay, 2 time slot of 1 hour each, which can satisfy the complete leads and are not intersecting with each other. So you have to ensure that if you are taking multiple time slot like 10, 10, 20, or 20, 20, or 10, 10, 10, 10, or 10, 15, 5, and 10, 10. Okay. So in that case, you have to see that they are not intersecting. Intersecting means overlapping. They are not overlapping with each other. If they are not overlapped, then that is fine. So we can split this new lease into 2 parts of 1 hour each and can schedule these 2 parts of the lease into the found time slot. That also provides a solution. However, like here, I have added a thing that is first you will go for single time slot. In the modified algorithm, you can think of first is single time slot. Then you go for multiple or several time slots. Right? If single time slot and multiple time slot cannot be found, you are not finding a single time slot in 4-node cluster, and you are also not getting several time slot in the 4-node cluster. Okay, to accommodate the new leech. Okay, then what you have to do? There is a need to check whether we can make space for new leads by perform resettling. Already accommodated deadline sensitive or not. So we will go for the process of again rescheduling. So remember, first algorithm, what you are doing? We are doing single time slot rescheduling using slack value. Second algorithm case, you are going for single time slot, then multiple time slot. Okay. Then if you are none of the condition is satisfied, if a condition is satisfied, you have to break. If the condition is not satisfied, then you will have to go for the process of rescheduling. So we are rescheduling already accommodated deadline sensitive leads. So to resolve it, 2 things are needed. Not only you can take a easy decision whenever you are thinking rescheduling. Rescheduling also having some condition. Like you can calculate the slack value, you can order them. For example, let us take L1, L2, L3, and L4 again. L1, L2, L3, they are already scheduled. When you are scheduling L4, you are not finding a single time slot. Also, you are not finding a multiple time slot. That's why you have decided to reschedule L1, L2, L3 based upon the slack value. But while you are rescheduling, let the order is you are getting L3, L2, L1, reverse order. Okay. After arranging them L3, L2, L1, you will come to know the deadline of L1 is violated. Okay. So because of L4, I cannot violate the deadline of L1. Right. That's why we need to check 2 things that need to be found. What are the things? First thing is that which lease should be rescheduled to make space for new lease. So like here I mentioned 3 leases, but when I take 100 leases, okay, like L1, L2, L3 up to L100. Then I'll take L101. So for L101, if these leases are already scheduled, okay, for L101, okay, I will not reschedule these leases. I will not reschedule these all leases because 100 leases rescheduling is very difficult. So you have to determine what are the leases that you need to reschedule. For example, somebody will say, we'll reschedule L95 to L100. That is the solution. 5 leases is okay. But going for 100 leads, 1000 leads, that is difficult, right? So you have to determine what are the leases that you need to reschedule to make space for this new lease L101 or L4, right? Next question says that how these leases should be rescheduled. I told you, by printing them you can reschedule. Okay, but you have to ensure that once you are printing them and resettling them, none of the deadline of the leases are violated. If the deadline is violated, that is not a good solution, right? So if the deadline is violated, for example, if while I am settling L3, L2, L1, then the L1 deadline is violated. Then I cannot violate one deadline to make a space for L2. That's why this resettling process is also very challenging, right? So let us understand the algorithm first. Then I'll tell you a simple example through which you can understand that how actually Haizea works. So this is the algorithm which I called as here schedule, deadline, lease using Haizea, right? So first is you have to calculate the slack value. Already I told you, you have to determine the slack value. The slack value is the difference between deadline minus start time divided by duration. Okay. So generally, if you go for rescheduling, rescheduling is required after single time slot, right? If you are not getting single time slot, then you go for rescheduling. But this procedure says that first you need to calculate the slack value. So till now we don't know, right, whether there is a rescheduling happen in our process or not. So initially we are checking the slack value for each and every lead. So after determining the slack value for each and every lead, okay, by performing this one, deadline minus start time by duration, you have to check that the slack value is less than equal to 1.1 or not. Now you may ask why I have taken 1.1 here. Why not any other value? That is a valid question. For example, let us take a lease L1 whose start time is 9, okay, and let's say deadline is 9:30, okay, and period is 29 minutes. Number of node is equal to 1. So over in a period of 9 to 9:30, what it requires? It requires 29 minutes out of 30 minutes. Okay, 29 out of 30. So if you calculate the slack value, it is 30 divided by deadline minus start time, that is 30, divided by duration, that is 29. Okay, so if I do 30 divided by 29, it is 1.03. So your slack value is less than is equal to 1.1 or not? Yes or not? Is it less than equal to 1.1 or not? Say yes or no.
Yes, sir.
Yeah, it is yes, right? So what we have to do? You have to reject this list. Okay, because somebody is asking you 29 minutes out of 30 minutes. Okay, somebody can ask you 30 out of 30 minutes. So at that time, the resource may not be available, right? So you have to give some buffer time. If you are asking for 29 minutes, at least you give buffer of 40 minutes or 50 minutes, like that, right? But if you are rigid about the deadline and your deadline is very near, so in that case, simply you have to reject it. But before rejecting any lease, so you have to initiate the process of negotiation. So what you can do negotiation? The customer who have submitted this L1, okay, those customers submitted the leases like this, we can request them to submit this lease in AR mode. In AR mode means what? AR mode has a specific start time and a specific end time. More or less, if you are agree to this particular leave, it looks like an AR lease only, because it will say 9 to 9:30. You have to give 29 minutes. So more or less, it is a AR lease only. So we can request the customer to submit this lease in AR mode, not in the deadline sensitive mode. Okay. Otherwise, you can request the customer, okay, to extend the deadline. The customer is extending the deadline, that is also fine. Suppose now it is extending it to 9:50. So you have calculated the slack again. If you calculate the slack, it is coming 50 divided by 29. Now this 50 divided by 29, how much you are getting? I think you will get 1.72. Okay, and 1.72 less than equal to 1.1, it is false. So we are not going to reject this lease. So outright, before doing outright reject, you can tell the customer to extend the deadline or submit the lease as a AR lease. Right? That is the overall goal. Otherwise, if the customer is not agree, then you have to simply reject that lease. Right? So that is the first step. If this condition is not satisfied, like if you have more time, then definitely this condition will not be satisfied. So in that part, you will come to the else part, right? What you are going to do in else part, you have to find a single time slot. You have to find a single time slot which can satisfy the complete lease within the deadline. Okay, find a single time slot. If it is a 40-minute slot, you have to give 40-minute slot. That is, you can say non-primitive slot. You cannot break them, right? But if the new lease is not schedulable as above, not schedulable as above means you are not finding single time slot, then you have to go for multiple time slot. Okay, you have to find multiple time slot which together can satisfy the complete deadline is within the deadline. So if 40-minute slot you are not getting, now you are looking for multiple slots. It may be 20-20, it may be 10-10-10 and 10. Okay, it may be 20 plus 10-10, any combination you can take, right? Okay, so multiple time slot if you find, but make sure that these slots are not overlapping with each other or intersecting with each other, right? But sometimes you are not getting a single time slot, you are not getting a multiple time slot. So if the new lease is not schedulable by any of the above methods, then you have to go for find leases to be rescheduled. There is a procedure. A call means you are calling a particular procedure which is finding the leases that need to be rescheduled. Okay, it is passing the new lease as a parameter. Okay, then append this new lease to leases. Okay, you have to append, you have to add the new leases to the leases. So I'll tell you this find leases procedure later. Okay, then once you are finding what are the leases that are going to be rescheduled, like I told you for L4, I want to reschedule L1, L2, L3. Right, I have identified it. Then I have appended the new lease is L4 is now appended. Then I will call reschedule deadline sensitive leases. Okay, now you identify what are the leases need to be rescheduled. Now you are calling a procedure that is reschedule the deadline leases to actually rescheduling them. First process is to identify them. Second process is to perform rescheduling. But after rescheduling also you found that let's say there is no improvement. No improvement means you found, let's say, instead of L1, L2, L3 order, you got L3, L2, L1 order. But here also L4 is rejected. Here also L4 is rejected. What you have to do? You have to roll back and you have to reject the new lease as it is not schedulable as above. Okay. In this way, you have to actually accept or reject the leases and deadline sensitive leases using the default, and multiple time slot concept is added to the default. That is an efficient algorithm over the default one that you can do. Okay, is it okay up to this? Any doubt up to this? Okay, if there is no doubt, then what you can do, I already told you on this example. Using this example, can you please try this? Already you have calculated the slack value. Let me write the slack value here. Slack value you already calculated. Let it is 2.25 and the second one is 3, then 3.34, then 2.25, then 6, 1.67 and 1.5. Okay, and can you please schedule these using Haizea algorithm? I'm giving you 5 minutes time. Can you please try? I already told you the procedure. Using that procedure, can you prepare the Gantt chart? Okay, prepare the chart, Gantt chart. Okay, by taking these 7 leases. Take a 4-node cluster. Okay, let me write a 4-node cluster here. This is 1, 2, 3, and 4. This is your node 1. This is node 2, node 3, and node 4. And start time is 9. So please try once by taking these leads using Haizea algorithm. Schedule the leases. And see how many leases are accepted and how many leases are rejected. Try once and see out of these 7 leases, already you have tried it in the previous class and your result is 6 and 1. That is number of accepted leads is 6, number of rejected leads is 1. Right? But I want the result using Haizea algorithm which we have discussed in today's class. See how many leases are accepted and how many leases are rejected. That actually you have to determine. How many leads are you getting as accepted leads? And how many leads are rejected? using Haizea algorithm. And is there any improvement over the existing algorithm which we discussed in the previous lecture? Not existing algorithm, but you can say without following Haizea algorithm. Okay, any solution? Okay,
Not-
let me solve.
Okay, sir.
Okay, have you solved?
Not yet, sir. Working on it.
Okay. So check my solutions also with you. If there is any conflict, please let me know. Okay. So here the first is, if you see, it is 9 to 10:30. We require a 40-minute slot, and for one node, so I can take a 40-minute slot here. So if it starts at 9, it will complete at 9:40. Right. Similarly, if you go for, this is for L1. Okay, let me color it so that we can figure out. Okay. Next, if you go for L2, it is again in between 9 to 10:30, but it is a 30-minute period, and number of nodes is 3. So after assigning L1, you can see here that out of 4 nodes, one node is only over. Rest 3 nodes are there, right? So if you start at 9, it will complete at 9:30, and these are the 3 nodes that are assigned to L2. Let us make it a little bit different so that we can figure out it. Right? Now, similarly, if you go for L3, right? L3 is in between 9 to 10:40. Okay, it is a 30-minute period, and number of nodes is 2. Okay, so it can start at 9:30, because after 9:30 you can see up to 9:30 all the slots are booked, and but L3 you will get time from 9:30 onwards, right? So if I take 30-minute slot, you can assign any node. There is no hard and fast rule. So if I assign these 2 slots, so it will take 30 minutes, 2 nodes, so it will complete by 10. Okay, so this is the space for L3. Let us make a little bit different. Okay, so that we can figure out it. Okay, so first 3 leases are now accepted. Now coming to L4, it is asking 4 nodes and 40-minute slot before 10:30. But you can see before 10, it is not possible to give a 4 node slot, right? And if you start at exactly 10, then as it is asking a 40-minute period, so it will complete by 10:40. Okay, it will complete by 10:40. But what is our deadline? Our deadline is 10:30, right or no? So it will violate our time deadline. Okay, so L4 is going to be rejected. Now you can see, as I already told you, in Haizea algorithm, we are finding single time slot. But even if you go for the multiple time slot case here, as 4 nodes are the 4 nodes are not free before 10, so multiple time slot case also you will not get a solution. So what you have to do, we have to perform the process of rescheduling. Okay. So what is the process of rescheduling says that? It says you have to look into the slack values of already accommodated deadline sensitive leads. So for example, L1, L2, L3 case, it is 2.25, 3 and 3.4 respectively, 3.4 respectively. Okay. So if I arrange them in non-decreasing order, okay, I showed you non-decreasing order because two leases may have the same slack value, right? So if you go for non-decreasing order, so you will get L1, L2, L3 in the same order because you can see 2.225 to 3, it is not decreasing. 3 to 3.434 also, it is not decreasing, right? So in this case, unfortunately, we are not finding any order, right? After arranging them based upon the slack value. So what we have to do? We have to finally reject lease number 4. Is it clear why we have rejected lease number 4 after resettling also?
Sir, could you please repeat on the slack value part?
Yeah. So see here, L4 is you are not getting for L4 case. It is asking between 9 to 10:30. 9 is here, right? 10:30 is somehow near like this. Okay. So within that you need a 40-minute slot, but the number of nodes is 4. But you can see before 10, all the slots are booked. Here some space is there, right? But it is maximum 2 nodes, right? It is maximum of 2 nodes, but all the 4 nodes are not free. If all the 4 nodes are not free, we cannot assign L4. Okay, so preliminary, you can see L4 is not able to get space. Okay, before rescheduling. Okay, we have not thought of rescheduling here. Okay, initially it is rejected. That's why we are going for the process of rescheduling. So if you go for the process of rescheduling, you have to choose the leads which are already accommodated. What are the leases already accommodated? The leases already accommodated is L1, L2 and L3. Okay. The leases already accommodated is L1, L2 and L3. These are the 3 leases already accommodated. So what we will do? We have to rearrange them. How to rearrange them? You have to determine the slack value. So you already calculated L1 slack value is 2.25. Here the slack value is 3. Here the slack value is 3.34. Arrange them in the non-decreasing order. So if you find the non-decreasing order of these 3 values, okay, then you will get the same sequence, right? Because 2.25 to 3, it is not decreasing. 3 to 3.34, it is also not decreasing, right? So the order what you will find in the resettling process is also L1, L2, L3, which is unfortunate in this case. So there is no change in the schedule. So if there is no change in the schedule here, then you cannot accommodate L4. So finally, after rescheduling, L4 is rejected. Before rescheduling also it is rejected. We hope that it can get a space in the process of rescheduling. But unfortunately, it is not also getting the space. So simply it is rejected. Is it clear?
Yes, sir.
Okay. Now coming to the next list, that is L5. L5 is asking a space from 10 to 11. In this slot, it is asking 10 minutes. So I can start here for 10 minutes. Let it be 10:10. Okay. And this is the slot for L5. Okay. Now, if you go for L6, L6 is again 10 to 10:50. It is a 30-minute period. Okay. 10 to 10:50. So 30-minute period, but it is asking only one node. So if you give this slot 10 to 10:30, let it be 10:30 here. So I can assign L6 here. Right. It is asking 30 minutes and one node, right? So we can assign here. Right. Now, if you go for L7 case in between 10:30 to 11, you need a 20-minute period, but the number of nodes is 3. So as the number of nodes is 3, we cannot give the number of node as 3 prior to 10:30. Yeah, you can do, but after 10-10 you can give, right? After 10-10 you can give, right? Because you can see there is a node vacant here, 1, 2, and 3, right or not? That's why I told you, order is not material. Okay, where order of the nodes is, each pair is immaterial. So if I give this node, then I can say this is L7. Okay, if it is start at 10-10, it is going to end by 10:30. Right? This is L7. This part is also L7. This part is also L7. Okay, so that is a 20-minute period. Let it be in dot format. I put dot. Right. So L7 is also now assigned here. So L5 is accepted, L6 is accepted, L7 is accepted. So again, the result you are getting here is 6 and 1. Right? Is it clear up to this?
Yes, sir.
Yeah. You can assign also after 10:30 also. After 10:30 also, if I assign here, let it be L7. Okay, then it will complete by 10:50. There's 20 minutes, right? 10:30 it will start, 10:50 it will complete. So anyhow, we'll assign before 10:30, not after 10:30, right? That is also a solution, but not a good solution than this particular solution. So in this way, actually, we assign in the case of Haizea algorithm. Okay. This now you can see this is another solution. Instead of assigning L7 in this slot, okay, what we did, we assigned L7 at 10:30. So it will complete by 10:50, and number of nodes is 3. So that is also a feasible solution, right? So what actually we did here? Now we first sort the leases based upon the slack value, that is D minus ST by P, and accordingly we make space. Okay, we are actually find the schedule L1, L2, L3, right? Unfortunately, we are getting the same order, but some cases you might get different order. Okay, but in this case, we are failed to accommodate L4. That's why we have rejected it. Right? That is the reason why we have rejected it. So, in order to improve this particular algorithm, there is another algorithm developed, which is the second algorithm, that is called as DPS. Okay, it is DPS algorithm. What DPS actually do? DPS will try to reschedule the already accommodated leases. Again, take the same example, L1, L2, L3, L4. L4 is rejected. For that, L1, L2, L3 need to be rescheduled. So it says DPS will try to reschedule the already accommodated leases. Already accommodated leases means L1, L2, L3 by finding multiple slots for L4. We have seen in the previous example, even if you are finding multiple time slots, practically it is not possible. Okay. However, it is also unable to accommodate L4. Single time slot also you are not getting for L4. Multiple time slot also you are not getting. Okay, as there are no multiple slots available, thus it is also going to reject it. Okay. However, the sorting process, if you look into the sorting process in Haizea, I told you, you have to sort them based upon non-decreasing order of the slack value, right or not? But when you go for DPS algorithm, the sorting order is based upon the decreasing order of number of nodes. Number of nodes, let's say it is n and it's more, right? So we have to sort them based upon the decreasing order of node n. So accordingly, it reschedule the leases in the order of L2, L3, L1. If you go for Haizea based upon the slack value, you are getting the same order. But when you go for the decreasing order of n, you are getting the sequences L2, L3, L1. But even if you do L2, L3, L1, it is failed to accommodate L4. Therefore, it actually roll back the scheduling and rejects L4. Roll back the scheduling means initial order is L1, L2, L3. But the order suggested here it is L2, L3, L1, which way rejected. Okay, as you are not getting a solution and the lease is got rejected, so we have to roll back this one. Right? So this is the algorithm followed in the DPS. So I'll tell you an example again, another example in which you can see how actually Haizea algorithm works and how actually DPS algorithm works. But before that, let us consider the algorithm that is used in the DPS algorithm. So first is consider S is equal to new leash. Let us take the old example again, L1, L2, L3 and L4. S is equal to new leash. What is our new leash here? L4. So sometimes multiple leases are available at a particular period of time. If they are available at a particular period of time, then your set may consist one or more elements. Like here it is only one element, but if multiple leases arrive at the same time and you are not getting a space, so in that case you can say uh, multiple leases are in that particular set S, right? Then while true, so it is always true. So you have to find SP. SP is your start period. Start period is nothing but maximum current system time and minimum start time of all the leases in S. So let us see what is the time for L4. L4 case, the start time is 9. Let me write here so that you can really understand the algorithm. Start time is 9. Okay. And obviously the end time or deadline is 10:30 only. And period and number of nodes we require, right? So period is your, you can say 40 and number of node is 4. 40 and 4, right? Lease 4 is rejected, that's why I'm considering lease 4. L1, L2, L3 already accommodated. Now I have to find SP, start period. What is the maximum current system time? What is the current system time? The current system time is 9. Okay, because at 9 only you have to take a decision whether L4 is accommodated or accepted, going to be accepted or rejected, right? So current system time is 9, right? Start time of all the leases in S. How many leases are there in S? There is exactly one lease. There is exactly one lease is there in the S. So what is the start time of that lease? Start time of the lease is also 9. If multiple leases are there, you have to consider their start time. Okay, if multiple leases are there, you have to consider start time of all the leases and then you find the minimum. So current system time is 9. Start time is also 9. So if you take minimum, 9 will only come. And if you take maximum of 9 and 9, you will get 9. That means start period is equal to 9. Is it clear? Line number 3.
Yes, sir.
Okay. Now come to EP. EP is your end period. Okay. Or you can say end last time, right? So maximum of deadline DI of all the leases in S. How many leases are there in S? There is exactly one lease L4. What is the deadline of that lease? The deadline of the lease is 10:30. Okay. If multiple leases are there, you consider the deadline of all such leases and find their maximum. So as there is only one lease is there, so you can conclude EP is equal to 10:30. Right? Now, this is nothing but two set. Using these two set, right, SP and EP, you have to create another two set or lease set. One is lease set 1, another is lease set 2. So in lease set 1, you can see all the leases not in set S. So if you take all the leases not in set S, who is there in S? L4. Not in S4 means except L4. I'm writing negation of L4. So L4 should not be included. All the leases not in set S. So S contain only L4. So L4 you should not be included. And having their schedule time inside the start period and end period. So start period 9, end period is 10:30. You take here, start period is 9, end period is 10:30. Right? So it is saying all the leases not in S. Not in S means S is contain what? L1, L4, right? All the lineages that is not in S, having their schedule time, okay, in between SP to AP. What are the lineages that is scheduled in these two period? One is start period, end period. Can anybody tell? Within SP and AP, what are the lineages that are scheduled? What are the lineages scheduled in between SP and EP?
Sir, all these except L7.
You tell me. All this except L7, he said. So actually it is L1, L2,
Yes.
L3, not L5, L6.
Oh.
Why? What is the reason? Can you please guess?
Mm,
The reason is that L5 and L6 will come into picture only after L4.
okay, sir. Okay.
While you are taking the decision of L4, L5, L6 is not in the picture. As you are seeking the looking into the complete Gantt chart, that's why you are thinking L5, L6. Okay. So
Okay, sir.
this lease set 1. Okay, let me write here. Lease set 1 is nothing but inside the start period and end period means L1 will come, L2 will come, L3 will come. Right? Now, lease set 2 is nothing but all the leases not in set S. Again, not in set S means except L4. Having the schedule time less than EP. Okay, having the schedule time less than EP. So you see the schedule time of L1, L2, L3, L1, L2, L3. Sorry, L3. Okay, not this one. Okay, the schedule time of L1, L2, L3. They are less than your end period. Less than your end period, true or not? And their schedule time is less than end period. First condition is satisfied. What is our second condition? Our second condition says that their end time should be greater than the start period. Look here, their end time of L1 is 940, end time of L2 is 930, end time of L3 is 10, which is greater than start period. Okay, schedule time is less than EP and end time is greater than SP. So that lease, those leases which are meeting these conditions, that will be present in the lease set 2. I can write lease set 2 is equal to L1, L2 and L3 again. Now, if the lease set 1 is empty, here in our case it is not true. And lease set 2 is also empty. First condition is lease set 1 is empty. Second state is lease set 2 is empty. If both are empty, then only you have to break. If both are not empty, then what you have to do? You have to do S dot add lease set 1. S means S is nothing but L4 and lease set 1. You have to add. Similarly, you have to also do S dot add lease set 2. So overall, you have 4 leases: L1, L2, L3, and L4. Okay. So this is your procedure number 1, which says that find leases to be rescheduled. What are the leases that need to be rescheduled? Come to second process. Second procedure is reschedule the deadline sensitive leases. So it is calling find order of leases by swapping. So when you prepare two different sets, let's say one set is having L1, L2, L3, another set is also having L1, L2, L3. What you have to do? You have to perform swapping. Swapping means L1 is swapped with L1. So there is no advantages. L1 is swapped with L2. L1 is swapped with L3. Similarly, L2 is swapped with L1. L2 is swapped with L2. L2 is swapped with L3. Similarly, L3 is swapped with L1. Okay, L3 is again swapped with L2. L3 is again swapped with L3. So you have to perform a process of swapping. Okay. That is the leases that is found in the procedure 1. Again, what is the guarantee? Swapping means it is a rescheduling only, right? So after swapping also, if you find that there is no solution, then you have to call schedule without considering backfilling. So there is a process called backfilling. What is the process of backfilling? Backfilling means if you consider a particular queue where you have set of leases, let it be L1, L2, L3, L4, L5. This is without backfilling. Without backfilling says that lease 1 need to be executed first, then lease 2, lease 3, lease 4, lease 5 in this particular order. But if you are not able to schedule them by performing swapping or schedule them without considering backfilling, then you have to consider backfilling. So what actually backfilling says that if L1 condition is not satisfied, whatever requirement L1 is giving, L1 is not satisfied, then you can move to L2. If L2 is not satisfied, you can move to L3. So it is placed in a queue. Queue says that always you have to exit the first one. If a new task is coming, you have to add in the rear end. But if the first one is not satisfied, you have to give chance to the second one. Second is not satisfied, go to third one, fourth one, fifth one, and so on. Right? So by considering backfilling, you have to perform it. And after swapping also it is not possible. Without backfilling also it is not possible. With backfilling also it is not possible. So finally what you have to do? You have to reject the lease. Okay, that means L4 is going to be rejected. Okay. Let us see the last procedure. So here I called a procedure that is find order of the lease by swapping. So that procedure is mentioned here. So what it says, sort the lease of lease set in the increasing order of deadline. So if L1, L2, L3 is there, you have to look into their deadline. Okay, let's say their deadline is 10:30 only for all the leases. Then they are already in the increasing order of deadline, right? Only when their deadline is different, okay, there the order may be changed. If the deadline is in the increasing order, let it be 10:30, 10:30, let's say it is 10:40. In that case also there is no change, right? Consider the lease up to new lease from lease set. Up to new lease means you will consider L1, L2, L3 and L4. Okay. Sorry, up to. So you will consider only L1, L2, L3. Okay. Consider the lease up to new lease from the lease set. Sort the leases up to the new lease in decreasing order of requested resources by bubble sort. How will arrange them? You have to arrange them based upon decreasing order of the requested resources. You have to look into how many nodes are asked by L1, L2, L3. Okay. How many nodes are requested by these L1, L2, L3. And you have to arrange them in the decreasing order. So in the case of Haizea, actually, you are finding the slack value. Based upon the slack value, you are ordering. But in this case, you have to order based upon the decreasing order of the requested resources. So this is the bubble set loop. Like for each lease in the lease set up to new lease. For each lease in the lease set up to new lease, if requested resources of the lease is less than that of the next lease. Suppose I am comparing L1 with L2. I have to check that number of requested lease, the number of resources requested by L1 should be less than L2. Then if after swapping, lease and next lease can be completed within their respective, not only you have to swap, but also you have to look into their deadline. Suppose L1, L2 case, they are meeting deadline. L2, L1 case, L2 is let's say not meeting deadline, or L1 is not meeting the deadline, then you have to cancel it. That's why it says that lease and next lease can be completed within their respective deadline, and requested resources can be allocated to them. Okay. Then swap lease and next lease, maintain the scheduling information while deciding the order of the list in the above described bubble sort. So you have to actually perform the bubble sort in order to make this swapping, right? So this is the algorithm which may look little bit complex for you as you are looking into for the first time. But if you go for understanding this algorithm, it becomes more easier, right? So let us take a small example to understand how actually this DPS algorithm actually works. So let us take this small lease set, right? I have taken 5 different leases, right? And let us first solve it using Haizea. Once it is completed, then we will go for the DPS algorithm. Okay. So let's say you are given with a 4-node cluster, node 1, node 2, node 3, and node 4. First lease, it is in this duration, right? 12 to 1320. This is your 12. This is your 1320. Okay, within this duration, you require 40 minutes. Okay, you need 40 minutes. So if you start at 12, it will be, okay, it will continue up to 1240, right? Okay. So if you start at 12, it will continue up to 1240. So it is a 40-minute slot, and it is asking 2 nodes. You can give node 1, node 2. You can give node 3, node 4. There is no issue. Okay, I have given you node 3, node 4. Better to give node 1, node 2 by following a common sequence, but node 3, node 4 is also a good solution, right? Any solution is okay, right? I already mentioned you uh, that different nodes, okay, their order is immaterial, right? Now coming to L1 is already scheduled. Now L2 also needs between 12 to 1320. It requires 3 different nodes. So I have started here because before this time, it is not possible to assign 3 nodes, right? So I have taken L2 from here. It is asking 20 minutes. So if it starts at 1240, it will complete by 1. Okay, and it is requested for 3 different nodes. Okay, once L2 is completed, again you can take 12 to 1320. You can take a 4 nodes, right? So before 1, it is not possible to get 4 nodes. So after 1, you can give 4 nodes. It is asking 20-minute period. So if it starts at 1, it will complete by 120. Right? So first 3 leases are successfully assigned to a 4-node cluster. Now coming to lease number 4. Lease number 4 is asking between 1230 to 1320. This is your 1230 to 1320. It is asking 1 node. It is asking 1 node for a period of 40 minutes. Is it possible to assign L4? Is it possible to assign L4? You have to take the time between 1230 to 1320. Okay. 1 node for 40 minutes. Is it possible? Can anybody tell? Within this duration, is it possible to get a 40-minute slot? Okay, if you start here, it is asking 1 node, right? It is asking 1 node. If you start here for L4, it will continue up to 1. What is the duration? 1 minus 1230. So it is 30 minutes. But what is your requirement? 40 minutes. Okay, so L4 cannot be accommodated. You cannot say that I'll assign this for this one, because I told you 2 consecutive slots, 2 overlapping slots are not allowed. They should not intersect with each other. So L4 cannot be assigned. If L4 is not assigned, then what you will do? L1 is assigned, L2 is assigned, L3 is assigned. L4 is not assigned. Right? If L4 is not assigned, right, then you have to arrange L1, L2, L3 in such a order using slack value and check. Okay, you arrange them in an order and check that whether you can accommodate L4 or not. So if you arrange them, if you calculate the slack value of L1, L2, L3, for L1 case, it is 1320 minus 12 divided by 40. So you will get 80 divided by 40, you will get 2. L2 case, it is 1320 minus 12 divided by 20. That is 80 by 20. So you will get 4. L3 case, it is 1320 minus 12 divided by 20. How much you will get? You will get 60 and 20, that is 80 divided by 20, you will get 4. So slack value of these are 244. If you arrange them in non-decreasing order, again you are getting it is 244 order. Okay, unfortunately you are getting the same order. The order in which you have scheduled it, in the same order it is again coming when you go for the slack value. So there is no other solution. What you have to do? Finally, you have to reject L4. Right? So as for Haizea, L4 is rejected. Now let us go for L5. If you go for L5, L5 is asking between 1240 to 1320. It requires 2 nodes for 10 minutes. 10 node slot is there. This is a 10 node slot, a slot. This is another 10 node slot. But it is only 1 node slot. It is not a 2 node slot. Okay, don't think that 10 node, okay, 10 minutes, 2 node means it is 20 minutes, 1 node. It is not, right? So L5 is also going to be rejected. So if you follow the Haizea algorithm for this example, then there are 3 accepted leases, 3 accepted leases, and 2 rejected leases. Okay, total lease is 5. There is another 2 parameter that is used as a performance measure when we go for the resource allocation batch. Okay, the first one is called as leases rescheduled. Leases rescheduled. We says that how many leases are rescheduled? Out of these 5 leases, how many leases are rescheduled? Is there any lease rescheduled here? Can anybody tell? Is there any leases rescheduled here? No. No leases are rescheduled. The number of leases rescheduled is 0. Okay, there is another parameter, okay, which says that leases insisting rescheduling. We says that how many leases insisted rescheduling. Okay, L4 insisted rescheduling, right or not? But unfortunately, we have not rescheduled any leases. L5 case, you are not getting the slot. Okay, even if you reschedule these, again it is in the same order. So L5 also insisting rescheduling. L5 also insisting, L4 is also insisting. But none of the request is accepted because they are already in the increasing of the slack value. So number of leases rescheduling is 2. Okay. So this is an example of your Haizea algorithm. But let us see if you solve the same problem using DPS. Okay. Let us see how actually it works in the case of DPS algorithm. In DPS algorithm also, you will assign L1 and there is no need of the slack value. DPS algorithm case, there is no need of slack value because it works with the number of nodes, not slack value. Slack value is only in the case of Haizea algorithm. Right? Now let us see L1, L2, L3 are ordered using DPS algorithm. Okay, L1, L2, L3 is already scheduled using Haizea algorithm. Right? Now L4 is coming into picture. L1, L2, L3, and L4 is now coming into picture. Right? Or not? So once you are getting a particular lease is rejected or you are not getting a space, what you have to do? You have to reschedule L1, L2, L3. For rescheduling, you are using slack value in the case of Haizea algorithm. But when you go for DPS algorithm, you have to arrange them based upon the decreasing order of decreasing, or you can say non-increasing order of the number of nodes. Like number of nodes in the case of L1 is equal to 2, number of nodes in the L2 is equal to 3, number of nodes in L3 is equal to 4. Okay, if you order them, which one will come first? If you arrange them non-increasing order, L3 will come first. L3 is having highest node, that is 4. Then L2 is coming into picture, 3 nodes. L1 is coming in picture, 2 nodes. Okay, and selection of L1, L2, L3 is also depend upon what? Your start period and end period. Right? So if you calculate the start period is the maximum current time. Maximum current time here it is 1230. Maximum current time it is 1230. And minimum start time of the lease is also 1230. So I am taking the start period is 1230. What is the end period? End period is nothing but maximum deadline. Okay, maximum deadline of all the leases in S. What is the deadline? There is only one lease. That's why it is 1320. So 1230, then 1320. Then if you look into lease set 1. Okay, lease set 1 says that the start period is here, right? And say end period is this one. So within this period, okay, you have to look into lease set 1. Whatever leases are scheduled between these two, you have to put in lease set 1. That means L1, L2, L3. If you go for lease set 2, what lease set 2 says that consider the leases whose schedule time is less than EP. Less than EP means this is your end period. This is your start period. So either L1, L2, L3, their schedule period is less than EP. And their end time is this one, 1240 for L1. 1 is for L2, and L3 case it is 1320. And this period is greater than SP, that is also true. So lease set 2 is also having L1, L2, L3. That's why I have selected L1, L2, L3 for arranging them in to perform the rescheduling process. Right? So once you arrange them, means first you will schedule L3, then you will schedule L2, then you go for L1. So you will get this particular order. You can see L3, L2, L1. Why you have arranged? Because L3 is having 4 nodes. L2 is having 3 nodes, and L1 is required 2 nodes. Right? That's why we arranged in this particular order. Now there are 2 leads left. Now see, once you arrange L3, L2, L1, will accept this order and will not roll back. Okay, will also not roll back if we can accommodate L4. If we cannot accommodate L4, we have to roll back. So if you see L4 is asking 1230 to 1320, it is asking a 14 node slot. So if it starts at here 1230, and it is one node, right? One node it is asking. So if it starts at 1230, it will complete by 110, right? 1230 to 40 minutes means it is 110. So now lease 4 is accepted. So this change whatever you made L3, L2, L1, it is accepted. Otherwise, you will reject it. Right? Now coming to L5. If you go for L5 is asking 1240 to 1320, right? Now 1240 is this one, 1320 is this one. What it is asking? It is asking 2 nodes. In fact, 2 node is not available up to 110. It is not available. You can see there is a 1 node is available here. So we can give 2 nodes at this particular period of time only. So if we start at 110, it will complete by exactly a deadline, that is 120. Okay. So if you go for Haizea algorithm, how many leases are accepted? You have accepted 3 leases, rejected 2 leases. But if you go for this algorithm, that is DPS algorithm, you have accepted 5 leases, you have rejected 0 leases. And if you calculate number of leases rescheduled, how many leases are rescheduled? How many leases are rescheduled? 3 leases are rescheduled. One is L3, another is L2, another is L1. And next parameter is number of leases insisting rescheduling. How many leases are insisting rescheduling? Okay, so you can see L4 insisted rescheduling. L5 has not insisted. L4 is insisted rescheduling. So answer is 1. Is it okay? Understood these 5 parameters? Is it clear? Or any question you can ask? Yeah, okay, it is clear. Now let us proceed to another algorithm that is called as alert time based resource allocation. Okay, already you know alert time, what we call token reservation. In token reservation, we have calculated token alert time, that is called as TAT. Token alert time, like you calculated slack value, right? Slack value, how you have calculated? The slack value is equal to, you can say, deadline minus start time divided by period. Similarly, alert time is nothing but it is deadline minus period. Right? For example, if you are given with these 7 leases, right? So if I ask you what is the alert time of the lease 1, then you will do D minus period. D is 10:30 minus period is 40, right? Is equal to, you can say, 9:50. Similarly, L2 case, it is 10:30 minus period is 30. So you will get 10. L3 case, it is you can say 10:40 minus 30. So you will get 10:10. L4 case, it is 10:30 minus 10:30 minus 40. So you will again get 9:50. Here it is 11 minus 10. So you will get 10:50. 10:50 minus 30. So 10:20. 11 minus 20. It is 10:40. Okay. Now you have calculated the alert time. Okay. So what we will do now, let us see how actually we proceed the alert time based allocation. So as I said, the alert time of the lease are calculated as follows. XC is equal to D minus ST. What is D? In the previous case, you can see the first lease. D is nothing but 10:30 minus start time. Start time is equal to 9. So how much you are getting? 10:30 minus 9, you will get ALT is equal to start time. Start time is 9 plus X minus P. X is 90 minus the period is P is 40, right? Minus alpha. Alpha is if there is some time in between to take the decision. Okay. Or whenever you are calculating, you are doing some computation, some lagging time is there, right? Okay. So if such a things are there, then that you can identify, that you can put in alpha. So the decision time is 5 minutes, then you have to subtract that time. So it is coming as 9 plus 15. So you will get 950. So what I told you here, I told you D minus P. D minus P means 1030 minus 40 is 950, right? But P is not in a time format, right? In order to make it a time format, we use these two formula. Otherwise, if you understand it correctly, you can do it 1030 minus 40. There is no issue. But as it is in time domain, it is also a time. We can find the difference of the time. That's why we did D minus ST. Once you did this one, then what you can do? You can do ST. ST is your start time, X minus period. X is a number and P is a number. That you can do it. Then you can make ahead of 9. Okay, you can make 50 minutes ahead of 9. Then you will get 950. And if there is any parameter you want to subtract due to decision making process, that you can do, where alpha is considered as the overhead time. Or simply you can do D minus P, which I told you here, right? To calculate the overhead. So this is, you can say this is one formula, this is another formula. Whichever you like, whichever you understand is easy, you follow that one, right? Now you can see, for example, for L1 we have calculated it is 950 by assuming that this overhead time is equal to 0. We assume that the overhead time is 0, but sometimes the overhead time also we need to consider. Okay, so now first step in the ALT array is to sort the leases in the ascending order of their start time. So if the leases are given like this, what you have to do? You have to arrange them increasing order of their start time. Because although you have start time and arrival time, which one matters you? Finally, it matters your start time, right? Suppose a lease is arrived at let's say 8. Okay, it is arrival time, but its start time is 10. So before 10 we cannot schedule, right? So ultimately it matters the start time, right? Okay, so first step is done. Then it divides the whole set of leases into groups. So we are dividing the leases into groups. How will decide that how many groups you form? And leads with the same start time are kept in the same group. Like if you see here, out of these 7 leases, right? These are the leases are having same start time. So they put in one group, that is G1. These two leases are having the same start time. So I put in a same group. Okay. And this is the lease, the single lease that is having a unique start time in comparison to other leads. That's why that is grouped in another group. So there are 3 groups of leads which have the same start time within each group. Okay. Now, what is the next step? Next, it calculates the alert time. Alert time of the leases within each group. Find the alert time of the lease within the group. Alert time I already calculated. So these are the alert times. These are the first 4. First 4. These are the alert times. These are the alert time, and this is the alert time. Now, within each group, allocates the lease such that the lease with earliest ALT is assigned first. Like if you go for G1, group 1, go for G1. G1 having how many leases? L1, L2, L3, L4. Right? So in L1, L2, L3, L4, okay, their alert time is 950, 10, 10, 10, and 950 respectively. Right? So it says that lease with earliest ALT is assigned first. Who is having earliest ALT? L1, L4. There is a tie. L2, L3 you can arrange in this order. But what about L1, L4? Whether L1 first or L4 first, that you have to make a conclusion. So it says, however, if there is a tie by looking into the earliest alert time first, okay, if there is a tie within the same alert value, then the lease with maximum n number of nodes. Okay, there is a lease with maximum number of nodes required is assigned first. Okay, so as there is a tie between L1 as well as L4, who is having maximum node? L4. So L4 need to be scheduled first, then followed by L1. Okay, L4, then L1, then L2, then L3. Right? So this approach has two advantages over the previous two algorithm, that is Haizea and Nathan. But it prevents the deadline of the lease. As you are arranging based upon the alert time, so deadline you can set, you can make respect to the deadline before the by looking into the alert time, you can decide that which lease is having more importance. Next, ultimately your resources are utilized properly. So after performing these groups and arranging them based on alert time, you can schedule it. Now, it is creating three different lease set. Okay, one set is called as STLT set. Okay, ST means start time and alert time. Like if you go for L1, what is the start time of L1? Start time of L1 is 9. What is the D deadline? Deadline is 10:30, let's say. So what is the alert time? What is the period? Period is 40. The alert time will come as 9:50. So you have to create three set. One is STLT lease set. STLT lease set means one lease set that is 9 to 9:50. So we define it as a set of all already accommodated leases whose duration is between ALT and ST. Okay, that is 9 to 9:50. Whatever leases are scheduled in between, that you will put in this particular lease set. In the previous case, you are creating two lease set, right? But here you have to create three lease set, right? First lease set is your ALT ST. Okay. Second one is ALTD. ALTD means 9:50 to your deadline, that is 10:30. That is another lease set. Okay, this is the lease set, all already accommodated leases whose duration between D to ALT intersect with the duration of DALT of a newly arrived lease. Then another one is ST to D. ST to D means it is 9 to 10:30. So you can say whatever things will come in 9 to 9:50 and 9:50 to 10:30, that will come in 9 to 10:30. That is the, you can say, superset. Okay, because here duration between D and ST interacts with the duration between DST of a newly arrived leads. Right? Now, the proposed scheme with the swapping, reschedule the leases by forming two sets. One is STLT and LTD. So STD is there, start time and deadline. In between we have LT. So we are creating one set STLT and another is LTD. Then we check that the interaction between these two sets are empty or not. Suppose there is a lease here, that lease would not be occur here. If it is not empty, then what you have to do? If the interaction is not empty, then it finds the difference between the lease set. Difference between the lease set means you will find STLT is equal to STLT minus of LTD. Like suppose L1, L2, L3 is there, you have to minus L1, L2, right? So it will come L3. Okay, it will come as L3. So what is your objective? Your objective is to make them disjoint. Next, the STLT is compared with the LTD. STLT is compared with your LTD. After making two sets, you have to compare them. So in the previous case, you have used bubble sort. So if there are m leases in one set, n leases in another set, or L leases in another set. So if two lease set is having m leases and L leases, the comparison takes order of ml time, right? But if the lease set is having n leases, right? First case, in ALT array case, is you are taking two sets. One is ST-ALT. Let's say in ST-ALT you have M leaches. And ALT-D case you have L leaches. Where these M leaches are different, these L leaches are different. There is no common element. So the complexity is order of ML. But what is there in the lease set in the DPS algorithm? Let's say it is M plus L. Okay, in the first lease set, M plus is also there in the second lease set. So M plus L means you can say let it be N. So here also N is there. So the complexity is order of N square. Okay, the complexity is order of N square type in the case of DPS algorithm. But if you say in comparison to this ALT algorithm, the number of comparisons is less. As the number of comparison is less, you can find your results in a better way, right? But they can be only swapped. When you are swapping one lease with another lease, which is present in one set, you are comparing two sets, right? You will pick one element from here, you will pick one element from here, and you have to swap. So they can only be swapped when the following two conditions are met. First condition says that each ST-ALT lease has less requested resources than ALTD. They have less requested resources. If they are more requested, then it is not possible. And interchanging ST-ALT with ALTD leads does not violate the deadline constraints. Remember, in rescheduling case, you can perform rescheduling by making sure that they are not violating the deadline. So if the newly arrived leases is not allocated after swapping, then it rolls back the reschedule. You are making space or you are making rescheduling in order to accommodate new leads. But after rescheduling also it is not giving, means what you have to do? You have to finally roll back it, right? So you can compare these algorithms using these leases. I already told you these performance matrices. First one is called as accepted leads. Accepted leads means total number of accepted leads in the data set. Suppose you have given 13 data sets into picture, then suppose out of 13, 12 is accepted. So number of leases accepted is 12. Rejected leads is nothing but difference between total number of leads 13. Okay, accepted leads is 12. So you will get 1. Then leases insisting rescheduling, it is the total number of leases which are trying to reschedule other assigned leases. Like I told you, L1, L2, L3, L4. These three are already scheduled. So L4 case, it is forcing L1, L2, L3 to reschedule. Okay. Then number of rescheduled leases, it is the total number of leases which are rescheduled to make the space for new leads. Like suppose I have arranged them in L3, L2, L1 order in order to accommodate L4. So total number of leases which are rescheduled is 3 to make space for the new leads. Okay. So there are 4 node specifications is given. I already mentioned the 4 node cluster we are using. And number of leases you can take in another data set. The number of leases is 11, 22, 33, and 44. That also you can try. And you can compare the performance of Haizea, DPS, and ALTRA algorithm. Right? Okay. So you can, once you compare, then you can see which algorithm is accepting more leads, which one is rejecting more leads. Okay. Obviously, number of accepted leads should be more. Right. You can compromise in these two factors: leads insisting rescheduling, number of rescheduled leases, because it will create your overhead. But number of accepted leads should be as maximum as possible. That you have to do. Okay. So let us stop here.